In this illustration, we'll be discussing about a ball falling on a viscous liquid. We are given that a spherical ball of radius 3 into 10 to the power minus 4 meter and density 10 to the power 4 kg per meter cube falls freely under gravity through a distance h before entering a lake of water. And we are given that if after entering the water, velocity of ball does not change, we are required to find the height h. Viscosity and g are also given to us. So here we can write the velocity of ball after falling through a distance h is, this velocity we can simply write as root 2 gh as it is in free fall and falling with a height h. Now in this situation, when the ball enters the lake, then the ball will be experiencing in downward direction its weight, which is mg. In upward direction, it will experience the buoyant force, which is equals to mg multiplied by rho of water upon rho of the solid. And it will also experience the viscous force on its surface, which is given by Stokes' rule, that is 6 pi eta rv, if the ball is moving with the velocity v. So we can write as velocity of ball remain constant in water. Here we can use the total force on ball should be 0. That means we can write the weight of ball mg should be equals to the buoyant force, which is mg multiplied by rho of water upon rho of solid plus the viscous force 6 pi eta rv. And in this situation, if we further simplify, this gives mg multiplied by 1 minus rho of water by rho of solid is equals to 6 pi eta rv. And here we can use the mass of ball to be density of solid multiplied by 4 by 3 pi r cube. This will be using as mass of solid, and v we can substitute as the value root 2 gh we already calculated. So if we simplify this relation, it gives us the value of v is equals to 2 by 9 r square g by eta multiplied by rho of solid minus rho of water. And here the value of v we can write as root 2 gh after freely falling through a distance h. And if we square the terms and simplify, this gives us the value of h, which is 2 by 81 r to the power 4 g by eta square multiplied by, this is rho s minus rho w whole square. Here you can see we are squaring this term and dividing it by 2g. So in this situation, this 2 gets cancelled out with this 4, and 1g also gets cancelled out with g square. So in this term, if we substitute the numerical value, then the value of h we are getting is 2 by 81 multiplied by r to the power 4. The value of r we are given with the 3 into 10 to the power minus 4 to whole power 4 divided by eta square. The value of eta we are given with 9.8 into 10 to the power minus 6 whole square multiplied by g is 9.8 multiplied by, if we substitute the densities of solid and water, then here we can write it as 10 to the power 4 minus 10 to the power 3 whole square. On simplifying this numerical value, will finally get the result as 1.653 kilometers. That is the result of this problem.